Okay, what we are doing here today is changing a light switch, simple 120 volt light switch at the DOT in Ames. And the very first thing that we were going to do is we are going to kill the power at the breaker. And with the power shut off, obviously, I have two switches here, and I am going to test voltage at each one of these. Verify breaker is off. And I'm going to check voltage at each one of these. I have 0, have 0. I want to make sure it reads 0 for my safety. I have 0, and I have 0. One breaker controls both of these switches. As you can see, this would be the feed for both, as it is paralleled off, one to each switch. And this red wire would be my switch leg on this particular switch. There we have one switch removed. Removed both switches. These are both on the same circuit, as I said, because they are paralleled off this one feed right here. And I'm going to reinstall switches. Gently fit the wires back in the box. This particular setup right here does not have a grounding conductor. As old as this building is, there's no ground here. A ground is what is used for our safety to operate a breaker. If something were to short out to this box, it gives the current a path back to the panel to make the breaker operate for our safety, and it's not here, although the wiring method in this situation is wired in conduit, so there is a metallic path back to the panel. There's usually a ground is identified by a green wire in color, and there's not one available in this panel. A lot of our buildings here are newer and updated more and actually have that grounding conductor there. Usually what I can do is put a grounding pigtail just to ensure that this strap is bonded to the box on these. I did not do it on this one. Okay, our job is complete.